Today I had to do some experiments on a TRAM half-wave VHF antenna base. So this is the antenna with the coil. Does not require a ground plane, but I'm going to use ground plane for better performance, and for that I had to use our shop Anritsu tool to maximize the tuning and the performance. So generally I go with a cutting chart. So when you buy this type of antennas that has a coil, generally not all the antennas have coil. The quarter wave antennas don't have a coil, but those require a good ground plane. And this one give me some gain. It's about 2.5 dB gain. So I get a narrow beam width, horizontal beam width, I would say, which gives me a better range. So that's the gain coming from. And before I modified it, before I replaced the cable, I did not like the measurement, the VSWR. And so I took it apart. I took that little foil at the bottom, took it out, put brand new cable, which is a bit better quality cable. Is made that goes all the way to VHF frequencies, and it's longer. So tomorrow I have a job that I need this longer cable. And if I look at the Anritsu, the VSWR, if you know that measurement, some people use just SWR. And if I look at the marker I'm getting with my body next to the antenna, so you see how the antenna is being affected, how you hold next to the coil or you hold it at the rod. So the objects around the rod, the antenna, the whip, is affecting the performance. So that's for those who are not aware of that. So if I put my hand at the top of the rod, right at the top, the tuning frequency changes. It goes lower. That's normal. And if I touch the coil, it will just decrease the performance, and it will affect the VSWR. And now the antenna, I'm just keep it on the concrete floor, and as you can see, I'm getting 1.15 at the frequency I'm trying to tune it, which is 115 is really good. 116 is about a megahertz, almost 2 megahertz up. So I have enough bandwidth for my my repeater I want to test tomorrow somewhere in the mountains, and it looks pretty good. So I don't really need a ground plane. So again, I had to use different cable, and I did a better grounding that the manufacturer did. So now I'm going to stack this thing on a large metal surface, assuming that I expect a better VSWR, but it's higher, 1.25 and 1.31. So I don't like it. It's too high. And now so that's on a long, heavy duty metal piece, part of a container. If I go somewhere, let's say here, I feel it gets stuck pretty good. I like it. So let's see what's the number now. Okay, it moved. Let me go to the markers and do the marker to the value. Marker number 6, no, number 5. It's 103. Have you heard of this type of VSWR on this type of antenna? Probably it's rare. So that's a really good number. Now on number 6, it changed a bit. Why? Because I have the coil next to this metal, which is affecting my antenna tuning frequency. So if I stuck it away from that, let me see the new tuning frequency. So it went higher. So I'm going to the marker to valley, marker number 5. The frequency went back up 104 and 114. So if you put some metal around these antennas, it's going to lower the tuned frequency. And you have to make sure you feel a good grip. Of course, depends on your muscle power. You may feel it too light. Some weak people may say, oh, it's it's stuck there, even is not a solid magnetic force. So what you need to have a very flat surface that gives you a very good grip. So right here we have some paint layers, and that is the reason I'm getting lower. It's a higher, actually. I was trying to say lower performance, but higher VSWR. But if I go on the other side, it's a better grip. I can feel it, and that's due to the amount of paint. So let me mount it to this solid metal. Okay. Yes, that's really good. So I feel I'm having hard time to pull it up. I mean, I could, but I don't pull hard because I want to be able to compare. So let me see what I'm getting here. The frequency moved up, the tuning frequency moved up a bit. So I'm getting 106, 105 at higher frequency. Let me do peak to valley 105 and 105. So it widened the bandwidth a bit. So 105 and 105. So 1 mega. No, actually, I'm wrong. So number 5. Okay, and I'm going market to valley to see the minimum. So it's 105, and now I'm going to marker number 6, and I'm going to tune it higher to the other frequency. I'm wrong. Marker 5. I'll do 168, 169, 168. Okay, that's about 168.270. That's my desired frequency. So 109 and 108. So I'm getting really good numbers if I stuck the antenna on this vise. So it tells you that the more metal structure you use to attach your antenna, let's see a drawer. It's not really heavy duty, and because the tip of the antenna goes next to some metal, some junk. But let me see. Ooh, that's something. So the frequency went lower, and let me do number 5. Yeah, the rod is moving, is keep bouncing around, but once it's stable, I see market to valley. Let's see, 104. So 104 at that 164 megahertz. So I would say the flatter, the cleaner, and the heavier duty metal, the better for this type of VHF lower frequency. For higher frequency, for UHF range, you need a smaller amount of ground surface. And so that's concluded my my testing, my experiment for today. I thought to share with those who are interested in ham radio antennas, how you get better performance. Generally, people experiment, but since they don't have expensive tools like this Anritsu tool. They do tests with basic power meter, reflectometer, or SWR meters, and they tune the antenna according to the minimum reflected power. So you have to put some power on that antenna and do experiments, then look at the SWR, maybe change the frequency up and down so you get an idea how that antenna behaves, if you need to cut more of that rod or a whip, or you want to put a longer one, things like that. So I used to do that type of stuff. So my battery seems that is gone and I have to let you go. It's time for me to move on to different projects. Take care, bye bye.